Hey guys, in this lesson we would understand how to determine domain and range of parent functions as well as their transformed functions. For understanding domain and range, it's very important to know transformations of the functions. We know there are 6 parent functions. First is fx is equal to x. No power means power is 1, so it's a linear function. Second is fx is equal to x squared. Third is fx is equal to square root x. Fourth is fx is equal to x absolute. Fifth is fx is equal to 2 to the power x, that is exponential function. And the sixth one is 1 over x, that is reciprocal function. Apart from knowing all 6 parent functions for domain and range, we also need to know the transform general equation. We know that is AFK x minus t plus c. And the last thing for domain and range that we need to know is which function has limit on x values and which function has limits on y values. Limits means restrictions. We also know that domain means any real numbers that x may take and range means any real numbers that y may take. Now always remember, because when fx is x to the power 1 or it's a linear function, the graph would look like a straight line. For example, this is the graph, and we notice that this line can be extended both ways. So it can take any x value on the left side, any x value on the right side. Similarly, it can take any y value in the downward direction and any y value in upward direction. So that means a linear function has no limits. When we say no limits, it has no limits on either x or y because it can be extended both ways. Limits or restrictions is an important concept when it comes to domain and range. So linear function has no limits on x or y. Now let's talk about quadratic function. We know the parent quadratic function is fx equal to x squared, and the graph of the parent quadratic function would look something like this. So as the graph of any other quadratic function, so it's going to be a parabola. Now if you try to extend this graph both ways, this graph is always going to keep going up. So when it comes to x values, it would have an increase in x value both on the left and the right side. But when it comes to y values, it will never go below this y value. It will only keep going up. Therefore, we notice that when it comes to quadratic functions, there is a limit, but there is no limit on x and there is a limit on y. Therefore, we can write here, when it comes to quadratic parent function, there is a limit on y. Because x defines domain and y defines range, we can say there is a limit on range. Let's talk about the square root function now. If we have fx equal to square root x, when you check one of the previous lessons, that is the graphing lessons, you would see that the graph of square root function looks like this, where the graph starts at x equal to 0 because we cannot have any negative values for x under the square root sign. So definitely there is a limit on x. And as there is a limit on x, we would not have negative values of y as well. So there is a limit on y as well in square root function. Therefore, we can conclude that in a square root function, there is a limit on both x and y, or we can say domain and range. Both have limits in a square root function. Let's talk about the next function, and that is an absolute function. An absolute function graph looks like this. We notice here that absolute function will always make our y positive, but for x we can put any value of x because if this graph is extended, it could be any negative or any positive value of x. Therefore, there is a limit on y. However, there is no limit on x. And we can conclude that here, that absolute function has limit on y. When we say limit on y, that means there is a limit on range. Let's talk about the exponential function. Exponential function looks like this. No matter what value we put for x, y is always going to be positive. So x has no limit. However, there is a limit on y. So we can say that in an exponential function, there is a limit on y again. That means there is a limit on range. When it comes to reciprocal function, a reciprocal function will always have asymptotes. Parent reciprocal function has asymptote on x and y axes. Asymptotes are basically imaginary lines. that can never be crossed by the graph. So the graph of this function looks like this. These lines of the graph will never cross x and y axes. So there is a limit on both x and y values. Therefore, we can conclude that for a reciprocal function, we would see a limit on x, that is domain, and we would see limit on y as well, that is range. So to write on domain and range, we just have to remember these limits, parent transformed equation, and know what domain and range means. Let's do examples to understand it better. If you're asked to find domain and range for the following questions, so we're given this question, all we have to do is just first understand what parent function it would belong to. Because our x has a power of 2, so this would be a quadratic function. Therefore, the parent is fx equal to x squared. We know in a quadratic function there is just a limit on range. Our parent function is y is equal to a f k x minus t plus c. F means the basic parent function, so this is square, that is replacing f. A is the number that's outside, so we can write down for this particular question a is -2. K is a number that is supposed to be multiplied with x and is supposed to be squared and has to be inside the bracket. Since it's not there, so k is 1. D is supposed to be this number, so D is 1 as well, and C is also 1. Now, how do we write on domain and range is? Domain can be written as XER, that means x can take up any real numbers, and if there is no limit, we just close the bracket. Make sure always write on domain and range with these squiggly brackets. Now to write down range, we would write down YER because range is any value that y may take up. However, this is a quadratic function, so there is a limit on y. So to write on limits, we make a line like this. And how do we read it? YER, where y is less than equal to -2. For any parent function where we see limits, we always put limit like this. Now, how do we decide how we put this is, we know from one of the previous lessons, the mapping formula, and we know mapping formula is written as x over k plus t, ay plus c. This tells us that x value is affected by k and d, and y value is affected by a and c. Therefore, range is also affected by a and c if there is a limit on range, and if there is a limit on domain, that would get affected by k and d. Since in a quadratic function there is just a limit on range, therefore range is going to be affected by a and c. Now, how does a affect? A is going to give us the sign. It could be greater than or less than sign. And C is going to give us the value. Greater than sign is going to be put when A is positive, and less than sign is going to be put when A is negative. Now, coming back to the question, in this question, A value is -2. Negative sign means we put less than equal to sign, and here comes the value. And the value is decided by C. We notice here C is 1, therefore we would put here 1. And this is how we write down domain and range. Let's take up another example to understand it in a better way. Let's say now we have a question 2. In the bracket, we have square root of -2x plus 1 minus 4. We know this is a square root function, so we'll go back and check that for a square root function, we have limits on what? And we get to see that in a square root function, we have limits on both domain and range. We know the general transformed equation is a k x minus t plus c. If f is not there, then we put whatever is that respective function is going to look like. So we put a square root sign there. Now we know a is 2, k is -2. Make sure k is factored out of x minus t bracket. D is -1 because the general equation has negative sign and this is a positive sign. So we would take opposite sign, and C is equal to -4. We know there is a limit on both domain and range. Therefore, in order to write on domain, we would put set brackets and we would put XER, where X effect is seen from K and D because mapping formula is X over K plus D. So K and D is going to affect our X value. K decides the sign. It's negative, so we would put less than equal to sign. And D decides the value. We are just going to put it as -1. For range, we would put in YER, where because y is also going to have limits. Y is affected by a and c. A decides the sign. A is positive, so we put greater than equal to sign, and c is the value that we put here. This is how we write on domain and range. Let's see how to write on domain and range when it is an exponential function. We have y equal to a 2 to the power of k x minus t plus c. So our a is going to be equal to -1. K has to be factored out, so that's why our first step for this equation is to factor k out. So 2 is going to be factored out of x and d, and we would get x minus 3 in the bracket plus 1. Now we have a equal to -1, k equal to 2, d is equal to 3, and c is equal to 1. We check here that in exponential functions there is just a limit on range. Therefore, domain would be equal to xer, no limit, we would close the bracket, and range will be equal to yer. There is a limit, so we would write down the limits using a and c. Y is going to be less than equal to, because this is negative sign, c value is 1. And you notice here that knowing transformations, mapping formula, makes our life really easy in order to write down domain and range. Let's say we have to write down domain and range for a reciprocal function. How do we know this is reciprocal function? Is because when x is as a denominator, parent transformed equation for a reciprocal function would be a over kx minus d plus c. So a would be equal to 3, k is 2, d is 1, and c is 4. For reciprocal functions also, we would notice that there is a limit on both x and y. That means we would write down the limits on both domain and range. Domain is xer, where there is a small change here, is we would not put greater than or less than equal to sign here. We would put not equal to sign. But the value here is going to be decided by d only, and that is x is not equal to 1. Similarly, range is yer, where y is not equal to c. And this is the only change in reciprocal functions. Everywhere else, it's the same rule that we have been following. We just have to remember that domain is written as xer. It has to be in set brackets if there is no limits on domain. However, domain is written as xer. If there is limits on domain, then we would write down either greater than equal to sign or less than equal to sign. And here goes the d value. Greater than equal to sign if k is positive, and less than equal to sign if k is negative. Similarly, for range, we would write down yer if there are no limits. However, if there are limits, then we would write down yer, where y is going to be either greater than equal to or less than equal to c value. Greater than equal to if a is positive, and less than equal to if a is negative. So this is a scenario of domain if there are limits, and this is the scenario of range if there are limits on range. The only difference to this scenario lies is when we are talking about reciprocal function, and the difference is that in reciprocal functions, this greater than and less than would be replaced with not equal to. Similarly, here also greater than and less than sign would be replaced to not equal to. And that is only in case of reciprocal functions. And this is how we do domain and range for parent or transformed functions.